Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and today we are going to talk about bivariate continuous random variables. This might sound complicated but don't worry, I will break it down step by step. If you have learned about single variable probability, this is just an extension to two variables. So let's get started. So basically this unit extends the concept of random variables in two dimensions for a discrete as well as continuous, and we will study their property, distributions and applications. We will also study conditional distribution and stochastic independence. In the next video we will explore problems and examples we will cover. So let us define a bivariate random variable. So what are continuous bivariate random variables? Thereafter, we will understand how to derive conditional distributions and density functions. We will analyze stochastic independence of two continuous random variables. This will come in the next video, but in this video we are going to learn bivariate continuous random variables. So let us see that the definition. So a bivariate continuous random variable is a pair. Both variables take continuous values. So x and y both will take continuous values and both are random variables. Remember, it is characterized by a joint density function. That is a joint probability density function. Thereafter, we'll see the examples. So the position of a particle moving in a plane, temperature and humidity recorded at a location. Now let us see joint cumulative distribution function. So that is fx, the value of random variable x is less than x and the value of y is less than y. And let us see joint probability density function in terms of cumulative distribution function. So you can get by differentiating capital F two times partially with respect to x and with respect to y. So we will get probability density function if cumulative distribution function is given. Now marginals, that means in joint distribution you can get just distribution of random variable x, and in this case distribution of y from joint density. So these distributions are called marginal densities. That means from fxy you are getting just fx. So that is marginal density of random variable x. And this one is from joint you are getting the density of y, that is marginal density. Conditional, like y given x. So you write fx fy given x. The same way f x given y you will write like this. So these are conditional density, and these are very applicable in machine learning and artificial intelligence, directly applicable. And two random variables are independent if fxy, their joint density function is equal to fx fy, and this implies that knowing x give no additional information about y and vice versa. That means both are independent. Let us see an example. So here we have a joint density distribution. So basically joint probability density function, you can say that, and see that the x lies between 0 to 1 and y lies between 0 to 2. We need to find the value of k. So let us see that how to find. So see that here, because we want to find the value of k. So if we differentiate from 0 to 1 and this one 0 to 2, so that should be equal to 1. Now see that here, first of all, integrate with respect to y and put the value of limits 0 to 2. So we will get this one marginal density function of x, and thereafter we will integrate it with respect to x. So we will get, and if we put the limit, so k is already there. So this we will get 2 plus 2 is equal to 1, and this will implies 1 upon 4. Now it is a given joint density probability density function where x lies between 0 to 1 and y lies between also 0 to 1. You also consider this one because this is very important. Even if this changes, this might not be a probability density function. So here very simple. So marginal means just getting distribution of x. So 0 to 1 6 xy. So here you will differentiate it with respect to y. Remember that. Thereafter, what will we get? We get a function in terms of x. So that would be marginal density of x. Why? We will differentiate it with we will integrate with respect to x, and just y would be outside, and thereafter you will get a function in terms of y. So that is marginal density function of y. Now what we have done? We have defined bivariate continuous random variables, explored joint and marginal distributions, conditional, stochastic independent conditional we have known, but we haven't done any questions. In future I will do. These are the answers. So hope you understood. For more videos, you can visit website www.postnetwork.co, YouTube channel. You can also follow Facebook page, and you can also connect to LinkedIn page of Post Network Academy. So hope you understood. Thanks for watching the video.